Solving trig equations with factoring, part 2. Again, I want to solve for x. I'm doing this by hand, working in radians, this time just giving solutions in the interval 0 to 2 pi. I'm taking a look at my equation here. Again, it's very complicated. I've got a cosine squared, a cosine. These aren't like terms. I need to get this thing down into this simple form. I can't ever get anywhere unless I can get it to cosine x equals a number, something like that. Well, the factoring method is certainly a good one to try. Remember, the factoring method can't work unless you have a 0 on one side. So I'll add 1 to both sides. That's very, very important. And then let's see, can I factor? Do I have a GCF? I don't this time because the 1 doesn't have a cosine attached to it, so there's no GCF. But when I see 3 terms and one of them has a squared, of course I'm thinking this was somebody's FOIL problem. Let's see if we can think this through. It's kind of like having 2x squared plus 3x plus 1. You could even jot that down on the side if it was helpful to you. How am I going to get that 2 cosine squared x? Well, the only way I can possibly think of where that could come from is a 2 cosine x times a cosine x. 2 cosine x times cosine x would be 2 cosine squared x. Let's see, obviously I only have pluses. There's no minus signs in sight. And I mean, look at the back. The back number is a 1. What else could that have been except 1 and 1? I better check to see if the middle terms work out. I'd have a plus 1 cosine x and a plus 2 cosine x. There's my plus 3 cosine x. And so it worked. We have factored the left-hand side. Since we have a 0 on the right side, remember, very important, it has to be 0, I can now say that I know either this 2 cosine x plus 1 equals 0, or the cosine x plus 1 equals 0. And just like that, we've taken our complicated trig equation and turned it into 2 simpler ones. If I can just solve these simpler trig equations and combine all my answers together, I will have the solution to the original equation. Let's see, looks like this one is becoming 2 cosine x equals -1, cosine x equals -1. This one's all set. Maybe I'll box it just to remind myself that it's done. This one still needs to be divided by 2. And so I get cosine x equals -1/2. Here's the 2 simpler versions of the equation, and that is the end of step A. Can I toss either of these equations out? Not this time. -1/2 is a perfectly valid cosine ratio, so is -1. That means I'm going to have to do step B twice, on the first equation as well as on the second equation. And that means I'll have to draw 2 different pictures here as I get into step B. Let's see, cosine x equals -1/2. So I'm having to figure out within one rotation, within one period, 0 to 2 pi, where could the cosine ratio be negative? Let's see, not in the first quadrant, second quadrant, third quadrant, not in the fourth quadrant either. So cosine can be negative in the second or third quadrant. So if I draw a reference triangle picture, I've got adjacent over hypotenuse, and then I've got a very symmetrical triangle here in the third quadrant, again adjacent over hypotenuse. We are working out this problem by hand, so this must be one of our special triangles, and a quick glance at it can tell you this is just a 30, 60, 90 triangle. It's the 60 degrees that's opposite root 3, so 60 there and 60 there. Which 2 angles am I looking for? Well, I have a second quadrant angle, and then I have a third quadrant angle. So those are the 2 angles within one rotation where the cosine ratio is equal to -1/2. And we should be able to write those down. Let's see, the smaller angle, if this part is 60, that leaves 120 for that angle. In radians, 120 is 2 pi over 3. And then the larger angle looks to be 60 degrees past 180. That would be 240, which again in radians is 4 pi over 3. So there are my 2 solutions for this equation within one period. How about the other equation, cosine x equals -1? Well, I see that -1, and I know I'm going to be drawing a unit circle picture. Let's see, the cosine ratio is the a coordinate, so I need a spot on this circle with an a coordinate of -1. This would be the only spot. There is no other place on this unit circle that has an a coordinate of -1. So the one and only one value of x that works for that second equation would be pi. Well, now comes step C, where I add in those multiples of the period, but I don't have to do that in this problem. I don't want all the answers. I only wanted the answers within one period. I'll just list them out and we'll be finished. We found 2 pi over 3, 4 pi over 3, and pi. And those are my solutions. Thanks for watching.